In the previous video, we defined what an intersection and a union, what they are. And remember that the general guideline is an intersection would be an and a union is an or. And the notation that we used for the two, the intersection had the arcing shape, because remember the arcing shape kind of looks like an A, and the union is a U shape, for U. So this set here, we have the intersection of A and B. The intersection, this is how we would read this, the intersection of sets A and B. That's what this notation means. And our sets are defined here. They're on your note sheet as well. But set A, we have the discrete list of integers, -1 through 4. Set B, remember we have the set of all x, such that x is an element of the interval 1 to 5, including the 1, or not including the 1, but including the 5. And remember here, the implication here is that x is also a real number. If it doesn't explicitly say that, then we assume that that is the case. And then set C, x is prime. Set prime numbers, remember, that would be 2, 3, 5, 7, 11, and so on. You know what prime numbers are. So when we have, or when we want the intersection of A and B, what this is asking is to tell what is in that overlap. What can we find in both sets A and B? Set A is this list of numbers. Set B is all real numbers between 1 and 5, including the 5, but not including the 1. So when we want to answer this question, it's just a matter of asking which of these numbers are also in this set. Which of the elements of set A are also in set B, because it's the overlap. We're looking for the and. Well, -1 and 0 obviously are not in the interval, and neither is 1. Keep in mind that parenthesis means that it's not including the 1. The 2 is, the 3 is, the 4 is, the 5, which was included in set B, is not in set A. And so the intersection of sets A and B then are the sets 2, 3, and 4. That list of numbers, because 2, 3, and 4 are in both sets. That's an overlap, an intersection, and so that's our answer. Let's take a look at the next one. A or D, the faster way of reading this. The union of A and of sets A and D, or just simply A or D. Now I want to list everything that shows up in either A or D. Well, look at that. We got -1, 0, 1, 2, 3, 4 here. We got 5, 10, 15, 20, 25 here. There's no overlap between them whatsoever. So the list of set of elements then is just 0, 1, or -1, 0, 1, 2, 3, 4, and then 5, 10, 15, 20, and 25. We just list everything that appears in either set. We're just imagining taking those two sets and pooling them together. That's what we're doing. So there's our answer. Keep in mind, if there were an overlap between these two, like if there were a 5 in this set here, we would not write it twice. We only write numbers. We only write our numbers one time. We don't duplicate things. So if there were any numbers that overlapped between sets A and D, they would only show up one time in the union here. Next question. C and D. We want the intersection of sets C and D. So C and D is how we would read this. Set C is the set of all prime numbers. This is infinitely big. There's no end to the number of prime numbers. Set D is obviously not. So set C and D then would be the set of all prime numbers that are in set D. And hopefully you realize that all of these are multiples of 5, which means that the only number in this whole list that is prime is 5. So the intersection of sets C and D is simply the number 5. And you can have a set that only has one number in it. You can have a set that has no numbers in it. That's all fine. So it all works. It's all good. So we'll move on. Next one. C or D. This is set C or D. C or D. Well, we have all of these numbers, all of the prime numbers, plus all of these. So we got 2, which is prime, 3, which is prime, 5, which we said is in both sets. Again, it appears in both. We're only going to write it the one time. 7 would be next, then the 10, then the 11. What comes next after 11? There's 13 is prime. 15 is not prime, but 15 shows up in set D. Then we have 17, which is prime. 19, which is prime. Need a little bit more space. 20 is not prime, but it shows up there. 21 is not prime. 22 is not prime. 23 is prime. 24 is not prime. 25 is in set B, or set D rather. And that's everything for set D. We just need to finish writing all of the numbers in set C. That's going to take a while. As we said, there's an infinite number of prime numbers. So once we get to this point, I'm going to throw in 29 here as my next prime number. But I'm just going to do that little ellipsis, that little dot, 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 to show that this actually continues. 31 would be the next number. 37 would be the number after that, the next prime number that shows up in this list. But they're all going to be prime numbers by that point, so we would just continue and say, yes, that pattern, that list continues forever. So that would be our list. We can have a union that is infinitely big, because after all, there's no end to the number of prime numbers. So we have that. Next one here. A and D. This is asking for the list of all numbers that appears in both A and D. So how many numbers appear in both A and D? There aren't any. There aren't any. There is no intersection. These are completely mutually exclusive from each other. There's no overlap. So how do we show that there's no overlap? It'd be a set that has nothing in it, right? It'd be an empty set. So we either write the brackets with nothing in them, make it right, or we do that circle with a slash through it. There's nothing. There's no intersection between A and D. There's no number that appears in both of these sets. Therefore, the intersection is the empty set. There is nothing. So that's it. Easy enough to do, I think. All right, last question here. What is the complement of C in the set given by A or D? So list this out again. That's the first step, really, that we should do for this. We're asked about A or D. You already did this, so it's already on your paper there. 0, -0, or -1, 0, 1, 2, 3, 4, 5, 10, 15, 20, 25. So that's A or D. This is a new word, complement. Complement with an E, not an I. Complement means opposite. So when I ask for the complement of C, C is prime numbers. The opposite of a prime number, you might remember this term, you might not. The opposite of a prime number is a composite number. So the complement of C, which we sometimes write C with a little apostrophe, would be the set of all x such that x is not prime. It's actually better to say just simply not prime. So that's what we're asking to do. We're asking to say, in this list, in this set here, which numbers are not prime? Easy enough to do. I'm just going to cross out the numbers that are prime. 2 is prime, 3 is prime, 5, and that's it. 1 is not technically a prime number. 0 is not prime. -1, that doesn't count either. So the complement then is -1, 0, 1, 4, 10, and then 15, 20, and 25. When we're talking about the complement of a set within a set, so the complement of a subset, you can kind of call it, just list out the entire set that we're looking at, the union set that we're looking at, and cross out everything that appears in what you're finding the complement of. We want to find the complement, which means that we want to get rid of everything that is in the set. A complement is a subset, or rather is the opposite. So if I want everything that isn't prime, well, that would be it right there. So there you go. That should hopefully be able to get you started with the questions on your homework. Again, if you need assistance, of course, feel free to come ask your teacher.